page 470 in your textbooks. Apologize for the voice again. Hopefully Monday when we come back, the voice will be better, but you have to suffer for one more day. Let's take a look at page 470, the homework section. You did just numbers 1 through 14 and numbers 1 through 9. Really basic equations. We've been doing these for a while. We did a great job with them on the quiz yesterday. Let's go through these very quickly. Number 1, Kirsten. 30. Nice and loud if you would. Yell the answer a little bit so the camera can hear it. Number 2, Jalen.
-7.
-7. Number 3, Elaine.
A equals 20.
20. Good. Number 4, Luciana.
12.
Careful, Corey.
-12.
-12. You divide that at -6. Signs are different. Get the negative. Let's go back to Luciana for redemption. Number 5.
12.
12 is correct. Number 6, let's go to Bryson, water bottle and answer.
18.
X equals 18. Number 7, Griffin.
3.
G equals 3 is correct. Number 8, Joel. 2 is correct. Number 9, Michael.
15.
Help him on number 9, Ben.
16.
Not 16, Bryson.
-2.
Should have a -2. We'll look at that in just a moment. Let's go back to Michael for redemption. Number 10.
A equals 8 over 3.
8/3 is correct, or 2 2/3. Number 11, Ben, back to you for redemption.
16.
16 is correct. And then number 12, let's go to Corey.
I didn't have that one.
Didn't have that one. Finish well.
Yeah, I think
Let's work through it right now, Corey.
I think I skipped
What do we need to do?
multiply the 3 and the x and the 10 and the 5.
Good. What do we call this, class?
Proportion.
A proportion. And what is Corey about to do?
Cross-multiply.
Cross multiply. Good. So we see the proportion, we cross multiply because, class, in any proportion, the product of the means equals the product of the extremes. So Corey, what is the product of the means?
3x.
And we know that that equals the product of the extremes, which is
10.
Jalen water bottle. And so what do we have to do to get the x by itself?
Divide by 3 on both sides.
Can 10 divide evenly by 3? Can this reduce?
No.
We're done. Now, if you want to say 3 1/3, you can. If you want to say 3.3 repeating, you're crazy, but you're not wrong. 10/3 don't make it easy. Let's take a look at 9, though, very quickly, because we did have a couple of people struggle with this one. Let's go back to Michael. What do we need to do first on this problem?
We need to take the positive 4 and add a -4 to both sides.
There we go. To get 9m equals
-18.
-18. And then, once we've done that, what do we do to now get the m by itself?
Divided
By 9. And 18 divided by 9, of course, is class 2, but -18 divided by 9 would be -2. And that's where we get the -2. Okay, questions on that? Yes, sir.
I didn't have it done. I didn't have 9 done.
I did not have 9 done, and that's why you were just kind of throwing a guess at the wall. Okay, questions on the 1 through 12? Yes, sir.
What was 10?
Number 10 was 8/3 or 2 2/3. Do we need to see that one worked out, Joel?
Yes.
Okay, what do we do first on number 10, Joel?
Add numbers to 44.
Which is,
-44.
watch class. -44 cancels, right? But -44 is a bigger absolute value. I'm going to put the -44 on top of the positive 12 because it makes it easier to subtract and keep the sign of the greater. Just a little strategy tip. If it's bigger, put it on top. That'll make it a little bit easier here, Joel, when we do the subtraction to get -32. And then, Joel, we've got to by, notice class, the negatives cancel, the 12s cancel. I left with A. Here the negatives cancel, don't they? Negative divided by negative is positive. And then, Joel, I can reduce both numbers by 4. That's where I get 8/3.
I thought it was -36 for some reason.
Okay, careful there. All right. Other questions on that? Any other questions on that? All right, read word problem 13 for us now. Read word problem 13, and let's go to Luciana.
The length of the garden is 3 feet longer than its width. If the perimeter is 14 feet. What is the length of the garden?
I saw a problem like this the other day that involved perimeter. And what shape are we dealing with here, Luciana?
A square? Wait, no. Rectangle?
A rectangle, because it mentions what two things? How do we know it's a rectangle?
Length and width.
It talks about a length and a width. And so if it's a rectangle with length and width, and it talks about perimeter, I need to remember the formula class for the perimeter of a rectangle. What is our perimeter formula, class? All right, so some of us are in 7th grade mode, some of us are in 6th grade mode. P equals 2L plus 2W, or P equals 2 times L plus 2 times W. We'll write it this way, right? And so the two things we don't know are the length and the width. And which one of these gets to be X, Luciana?
The width.
The width, because in the comparison sentence it says,
the length of the garden is 3 feet longer than its width.
all right, so if the width is X and the length is 3 feet longer, what is the length?
X plus 3.
How many of these two unknowns represented this way? Any questions on why we have length is X, width is X, length is X plus 3? But when we go to plug it in class, it's not length plus width equals perimeter. It's 2 lengths plus 2 widths equals perimeter, right? So my perimeter, which it says is 14 feet, equals 2 lengths, X plus 3 plus another X plus 3, plus 2 widths, X and another X. Does that make sense? Or if you prefer, just like that. Now, you remember that distributive property that said you could multiply the 2 by the X and the 2 by the 3? What is 2 times X, class? 2X. And what's 2 times 3? And what's 2 times X? So do you see that really, class, we have how many total X's here? 4X. Or if you'd written it this way, X, 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 that's 4 X's. 3 and 3 is 6. Eventually, one way or the other, we get to this point right here. How many got to that point right there? Just curious. Only a few of you. Those who didn't, that's okay. Does it make sense now? You've only seen this twice. Does it make sense now? All right, now we just got to finish it out, Luciana, talking through.
So subtract -6 from both sides to get 8 equals 4x.
And divide away the 4 to get X equals?
2.
All right, so what's 2?
X.
Right, so what's 2?
Oh, the width.
The width is 2
feet.
2 feet. All right, so you got it, because you don't need your help. All right, what's the length then, Luciana?
5 feet.
5 feet. And then we have 2 foot by 5 foot rectangle. I have questions on the algebra there. Questions there. Good posture then. Head off hand. All right, read number 14 for us then, if you would, Griffin.
The winner of a reading contest read 4 times as many pages as Josh. If the contest winner read 800 pages, how many pages did Josh read?
All right, how many unknowns do we have in the problem here, Griffin?
2.
2. At least it sounds like 2. Who are the 2 people mentioned?
The winner and Josh.
The winner and Josh. But really, only one of these is unknown. Because we actually know how many pages the
Winner read
he read how many?
800.
800. Josh, however, we don't know. So we could just represent him
X.
All right? Now, that first sentence, read it again for me.
The winner of the reading contest read 4 times as many pages as Josh.
The winner. Okay, the winner. Class, what do I write? 800, because the winner read 800. And then it says he read, class.
4 times.
Read, class. That's a verb. It's a sign. 4 times as many as Josh. What do I write, class?
4x.
How many of this equation? 800 equals 4x. Then we're just going to divide by 4. What do we get for our answer here, Griffin? Divide by 4.
200.
200 pages. There he goes. How many pages did he read? He read 200 pages. How many 200 pages for you answer? All right, questions on those word problems. All right, flip over to page 479 now. Page 479. I want to talk to you about another kind of equation. We've been solving all kinds of equations lately. We've done word problems lately that use equations that we're solving. And talk today about something called a pure quadratic equation. Here's the key with the quadratic. It has x squared in it. That's what makes it quadratic. So it's a cool, fancy sounding word. Bottom line is it's got an x squared. Like what you see in the little blue shaded box here. X squared equals 4. Well, we know this, class. If I had x plus 3 equals 4, what would I do? Minus 3. Why? Because that's the opposite of plus 3, right? Hey, pay attention up here. You don't need to look it up there. If I got x minus 3 equals 4, class, what do I do to get rid of the minus 3?
Positive 3.
Positive 3, because that's the opposite of a negative 3, right? If I had 3x equals 12, what would I do to get rid of the 3? Because that's the opposite of multiplying, right? If I had x over 3 equals 4, what would I do to get rid of the 3? Because that's the opposite of dividing by 3, right? What's the opposite of a square? A square root, right? For instance, if I give 3 and I take 3, that cancels. If I multiply by 3, divide by 3, that cancels. Well, if I were to square something like, say, a 5, class, 25. To go back to what I started with, I'd have to take the square root, right? So all we have to do, and you see this in the blue shaded box, is take the square root on both sides. The square root of x squared, class. And then the square root of 4 we know is
2.
Although technically, there are 2 square roots. Because if I multiply 2 times 2, class, I do get 4. But if I multiply negative 2 times negative 2, we know we also get 4. So when I take the square root of 4, there's actually 2 of them. A positive 2 and a negative 2. But I'm lazy. I don't want to write it like that. So the shortcut is what you see in your book there. Positive, negative 2. And that little symbol just means both the positive 2 and the negative 2. It's the mathematician lazy way of writing 2 answers at the same time. Flip the page. Flip the page. We got another one for you that I think you can do pretty much in your head. X squared equals 144. Class, I've got to get rid of this square. It must say x equals when I'm done, right? I can't have a square, so I got to get rid of square. What is the opposite of square, class?
Square root.
Class, what's the opposite of square?
Square root.
So when I see x squared, what do I got to do?
Square root.
On
Both
both sides. Because what we do one side,
Gotta do the other.
and of course the square root and the square cancel. Just like 3's cancel, or 3's cancel, or 3's cancel, or 3's cancel. They cancel each other. I get x. And I gotta think, square root of 144. What times itself gives 144, class? 12. But not just 12. Negative 12 as well. But rather than writing 12 and negative 12, I'm lazy, so I'm gonna write positive negative 12. Do we see that? Still seem pretty easy. Not blowing anybody's brain here today. All right, look at the one below it though. Oh, 2x squared plus 1 equals 9. Oh, what do we do here? Well, the goal is to get x by itself, right? What is the least attached thing to the x?
Positive 1.
The positive 1. Now you see the 9, well, it's not even in the same room. It's on the other side of the wall, right? But the 1 is less attached. The 2's being multiplied. The square is part and parcel of the x nature, but the 1 is completely detached. Let's get rid of the 1, class, by putting a
Negative 1.
on both sides. That gives us 2x squared equals
8.
Now, the multiplication is less attached than the exponent. So let's get rid of the 2 now, class. And that gives x squared equals
4.
Now, at the very, very last, I get rid of the squared by taking the
Square root.
And when I take the square root of x squared, class, is just x. But when I take the square root of 4, there's 2 square roots. They are, class?
Positive negative 4.
Positive negative 2. There we go. Do we see what we're doing here on these quadratics? So not real hard, it's just a little different because instead of adding, subtracting, multiplying, or dividing, we're taking a square root. A little bit different. Look across the page. I want you to try numbers 1 through 11, the odd. We're on page 481. Page 481, 1 through 11, the odd. A few people finishing up. Take another minute or so to get as far as you can on these, and then we'll take a look at them together. Let's take a look at these together. Even if you're not finished with all of them, pencil down, good posture. Let's keep head off hand. I know we're tired here at the end of the year. Got the air conditioning on finally because it's getting kind of warm in here, but hang in there with me. The very first problem, there's just one step, class. We just have to take the
Square root
of
y.
both sides. Both sides. And when I take those square roots, then square root of y squared, y, and the square root of then. And I know you can't hear too well, so try to listen very carefully because I know it's quiet. And we take the square roots of 81 then.
9.
Well, that's one of them.
9.
Class?
9.
Positive and negative 9, right? Because negative 9 times itself would also be a positive 81. So positive and negative 9. Look at the next one. Bryson, what do I got to do?
Square root on both sides.
There we go. To get?
X equals positive and negative 2. 1.
Positive and negative 1, because sure enough, 1 times 1 is 1. Yes, sir.
Like on the last one, how would it be negative if it's positive 81?
Because a negative times a negative gives you a positive.
But you said a positive and a negative.
Right. Positive 9 times positive 9 equals positive 81. There's 2 possible answers then.
Oh.
Yeah, that's what makes the quadratic kind of interesting. Both the positive or the negative, either one of them would give me an 81 if I squared it, if I multiplied it by itself. So by writing positive negative 9, it shows that both of these things could be the y, right? If we plugged it in, we said positive 9 squared equals 81. Well, that checks. But if I said negative 9 squared equals 81, well, that also checks. There happen to be 2 answers here, a positive and a negative. Does that make sense? So yeah, kind of a little bit different than what we're used to here. How many have the positive negative 1 on number 3? Look at number 5. Let's go to Jalen. What do we need to do here?
Negative 69.
Good. We're not starting with that square root. Get rid of everything else first. Get rid of the 16. Then we have r squared equals.
I didn't finish it.
Oh, the pain.
Wait.
10 minus 6.
4,
5 minus 1.
4,
1 minus nothing.
1.
144. All right, now that we've got just the r squared by itself, now we're ready to take the square root of both sides. And Jalen, what should we have?
R equals positive negative 5.
There we go. How many had those answers for number 5? Number 7, what do we need to do on this one here, Kirsten?
Combine 2 and squared.
Excellent. You can't have 2 different m squares. You gotta mush them together. 2m squared, 2m squared.
4m squared.
Now we can go about our normal routine, which is to do what next?
Divide the 4 on both sides.
Good. Get that 4 out of here. That way we've got the m squared all by itself equal to
36.
36. Now we can,
Square root.
on both sides, to get
Positive negative 6.
m equals positive negative 6. Great job. How many had those same answers on number, I guess that'd be 7? Excellent questions on that. Yes, sir.
For every single one, I forgot to put the positive and negative.
It would be minus a point if you forgot the positive negative. So not completely wrong, but minus a point. There are some mathematicians who would argue, well, he got half the answer wrong, so it should be minus 5. I don't do that, I just do minus a point. But you'll remember it the next time. All right, go to the next one. Joel, what do we need to do?
You need to add 25 to the negative 25 to both, and then you get a squared equals 100, and then you get the square root of a and 100. A equals 10. Positive negative.
There we go. How many had these answers on number 9? All right, Ben, let me come back to you here. What do we need to do on this last one, Ben?
Add 10.
Add 10 to
Both sides.
get x squared equals,
21.
then what?
Square both sides.
Now square root. Square root of both sides to get
X equals 11.
close. There's
Positive
2
of negative 11.
positive, negative 11. Great job. How many had that on number 11? All right. Go back into the evens now. Now we've had a chance to see the odds. Maybe we made some mistakes. That's okay. Maybe we forgot positive negatives. That's okay. We learned from it. Go back and hit the evens now. When you finish the evens, stand beside your desk. Two through 12 even. Just leave that aside for now.
don't know this.
Let's do it with some flair. Such a simple thing as standing, and y'all make it so hard. All right, have a seat. Have a seat. Thank you. All right, let's take a look at these together. Joel was first. Joel, you're up. Nice and loud so the camera can hear you. Number 2.
Positive -7.
Positive -7. Number 4. We had to use a little creativity here. What did you figure it out to be?
Positive -15.
Outstanding. Folks, we know 12 squared is what? Class?
144.
144. So 225 has to be something bigger squared, right? And it ends in a 5. Well, if it ends in a 5, the only way to get something that ends in 5 is to have a multiple of 5, right? That's what tells us it's divisible by 5. So it can't be 5 squared, that's 25. The next available things are 15 squared or 25 squared. Well, which one's easier to try first?
15.
Let's try the 15 squared. So you multiply 15 times 15. Hey, it's 225. And that's how you figure that one out there. Now, I will say, for those watching on video, I did pass out the handout that you see in the description of the video, which is a list of squares and square roots. So those who have that, if you look down the square column, you don't have to go too far to find 225 on that second column in. And right next to it, you see that 225 is the square of 15. And you see that there. Okay, we'll be having that handout for the next little bit that we work. Number 6, back to Joel.
I thought it was 5. Oh wait, never mind.
Number 6, what did you get, Joel?
Positive 10. Positive -10.
Positive -10 is correct. Number 8.
8. Oh, I forgot to spell positive.
Oh, all right. Second was Michael. Michael, are you good so far? All right, Michael, did you have positive -8 for 8?
Yeah, I had positive x equals positive -8.
Good. And you got all the correct answers on the first 3. All right, what did you get for number 10?
I had y equals positive -4.
Oh, all right. Let's see. I think Jalen was third. All right, Jalen, are you perfect so far? What did you get on number 10?
Positive -2.
Positive -2 is correct. And number 12, what did you get for your answer, Jalen?
Positive -10.
Positive -10 is, oh. Number 10, the answer is positive -2, but she had positive -2. And so we got to address that. Let's see, who was after Jalen? I think it was Bryson. Bryson, were you perfect? No. Corey was, no. Luciana was next. Luciana, were you perfect? Corey, were you perfect? You were. Fact check this. No, not perfect. All right. So, excuse me. All right. You need tissue? Okay, I'm going to take questions. All right. So no candy this time. All right. Questions on any of these? Yes, sir.
All I forgot was the positive -.
I
If
know.
I would have remembered that, I would have gotten all of
You
them.
would have gotten, but you didn't. All right. So Ben, you had a question. Which one, sir?
Can you do 6 and 10 on the board?
Yeah. So number 6, with a g squared over 25 equals 4. Ben, what do I have to do to get the g squared by itself?
Divide the 25.
Not divided. It's already being divided. I have to do the opposite. Multiply the 25 on both sides. That cancels to get g squared equals 100. That's where we get the positive -10 from when we take the square root. And then you said number
10.
Number 10, yeah, several of you on number 10 had some issues. Let's take a look at that together. Jalen, let me come to you. What do we do first?
So we multiply, never mind, I'm brain. Subtract 25 both sides.
But I'm going to put the -25 above the positive 17. We get -2y squared equals -8. Remember I said in class if both sides are negative, cancel the negatives off. Just make them both positive. Or when you divide away, Jalen, the negatives cancel. Now, either way, we wind up with a positive 4. That's why when we take the square root, we get positive -2. There's not a -2 at that point. Does that make sense? All right? Does that make sense, number 10 for you? All right, any other questions besides 6 and 10? All right, anyone just missed one? All right, good. Questions on these? Look at the little fast fact, if you would please, right above all of this. And we see something that you're going to get into a lot more next year. This year we're just going to touch a little bit on it. And that's one of the most important applications of these pure quadratic equations is something called the Pythagorean Theorem. How many have heard of the Pythagorean Theorem before this? All right, the Pythagorean Theorem describes the 3 sides of a right triangle and how they relate to each other. Now, you might feel like this is a little bit math nerdy, but in sports, big time application here. When I'm striping the PE fields for volleyball, the racing lanes for field day, soccer field, I have to have a perfect right angle. You know how I said a perfect right angle? I got to do a little Pythagorean theorem. Because if I make sure that I've got a Pythagorean theorem relationship in 3 sides, I know I've got a perfect right angle. Otherwise, I'm just eyeballing it, and I tried that one year, it didn't work too great. I ended up with a weird parallelogram for a soccer field instead of a rectangle. It was really sad, okay? So I thought you've got to do a little bit of math on that. Here's the key. In a right triangle class, there's always a right angle. The side across from the right angle is called the hypotenuse. Say that word.
Hypotenuse.
Again?
Hypotenuse.
Hypotenuse, okay? And so the hypotenuse is a fancy word for the side across from the right angle. Now, I think last year, y'all might have learned something about the hypotenuse. It's always anyone learn this? The longest side. It's always the biggest side. Now, that's not a good way to remember it. Just remember it's across from the right angle. Now, these 2 sides here, they make the right angle, right? They are perpendicular to each other. We call them legs. Why? I don't know. But we call them legs. So this is a leg, that's a leg. Pythagoras, the great Greek mathematician, he's credited with discovering this relationship. He discovered that if you take the square of one leg's length and the square of another leg's length and add them together, it always equals the square of the hypotenuse. He put it this way: c squared equals a squared plus b squared. Say that with me, class. C squared equals a squared plus b squared. So, put it up in color now. With the Pythagorean theorem then, the a and the b are the legs. This is a, this is b. Unless you're like Bryce, you're like, I'm a rebel. I want this side to be A. I want that side to be. I live dangerously. All right, fine. Let that be B and that be A. I don't care which leg is which. The legs are A and B. Got it? The key is the hypotenuse is C. Now here's the pitfall. C isn't always the slanty side. Now C is the straight side. A and B are the slanty sides. Now it's the slanty side again. Now it's a straight side. A and B are the slanty sides. Does that make sense? As long as it's across from the right angle, that's the hypotenuse. So look in your textbook. We got that little fast fact thing there. And they say that let's suppose that we've measured out the legs of this right triangle. One of the legs is 2, they say inches. They don't even say inches. Let's just say it's 2 inches. Let's say we got a leg that's 2 inches, and we got a leg that's 4 inches. And we don't know how long the slanty side is. Really straightforward. You go to the formula. The C represents the hypotenuse. So, which side don't I know, class? So therefore, I don't know what to plug in for C. So I'm just going to leave it C squared. But I know the legs are 2 and 4. So as you see in the book, we plug in 2 and we plug in 4. We square the 2.
4.
We square the 4. Careful, 16. And we add 4 plus 16 to get 20. And now in our pure quadratic, we take the square root. Now there's just one problem. I don't know what the square root of 20 is. That's why I have a little paper. What is the square root of 20, class?
4.472.
About 4.472. So that's the length of this line. Notice it's a little bit bigger than the 4. It's that little bit bigger. Now, you can set your books aside. Keep that handout out. Got another handout for you. Again, if you're watching on YouTube, get a Pythagorean Theorem handout there in the description of the video. Let's work through this thing together. Top line of the handout, all I need you to do is put an arrow next to the side that is the hypotenuse. Draw an arrow to the side that is the hypotenuse. Remember, find the right angle, it's the little box, and look across from the little box. All right, let's make sure we found them. On the first one, it's right here, across from the little box. On the second one, it's right here, across from the little box. On the next one, it's right here, across from the little box. And on the last one, it's down here, across from the little box. How many got all 4 hypotenuse correct? Hypotenuses correct. All right. That's important that we're able to identify the hypotenuse. Now look at the next row. Do you see on that first triangle, class? I've labeled the 2 legs, but I haven't labeled the hypotenuse. Look at the next one. Do you see on the next one? I've labeled the 2 legs. I have not labeled the hypotenuse. And on the last one, class, I've labeled the legs, but not the hypotenuse. Do we see that? In each of these instances, the directions say, find the hypotenuse. Class, what letter do we use to represent the hypotenuse? C. C is the hypotenuse. Now, the hypotenuse is going to be squared, so we're going to square the C. It's going to be C squared equals the A and the B, class. These are the legs. So C, class, is the hypotenuse. Try that again, class. C is the hypotenuse. A and B are the legs. All right, so on that first problem on the next row, I know how big the legs are, class. They are
6 inches and 8 inches.
All right, so let's do this. Right below the triangle, write this down. C squared equals 6 squared plus 8 squared. Just write that out. C squared equals 6 squared plus 8 squared. Now, I can't do nothing with a C squared, but I know what 6 squared is, class.
36.
And I know what 8 squared is.
64.
And I can simply add those 2 values together.
100.
Comes out nice and easy to 100. Now that we've got it simplified down, I see my pure quadratic. How do I get just C equals, class?
Square root.
Square root. Now, Joel, when I take the square roots of 100, what are they?
Positive and negative.
Positive and negative 10, but this is talking about a length, right? Can you have a negative length?
No.
No. You can be short, but you can't be negative height, right? Like, you might only be 5 feet tall, but you're still positive, right? Michael's over there like, yes, short people forever. Okay, so even if it's a short length, it's still positive. So I'm not going to put positive, negative if it's a length. I'm just going to say 10 inches. And draw that on that missing side, right? So I already had 6 inches here, I had 8 inches here. Go and write 10 inches here and circle it. Does that make sense? Look at the next one. I got a 5-foot side labeled and a 12-foot side labeled. But class, these 2 sides are the legs. This is the
Hypotenuse.
The hypotenuse we represent with the letter C. The legs are represented with the letters
A and B.
A and B. And we know the Pythagorean theorem says, class, C squared equals A squared plus B squared. So, what do I write for C squared?
Nothing.
C squared. What do I write for A squared? 5 squared. And then for the B squared, I could put,
12 squared.
what if you said 12 squared plus 5 squared?
Same
Thing, right? Doesn't matter, okay? Because they're being added anyway. That's why it doesn't matter which leg is which. Now, we know that 5 squared class is,
25.
and 12 squared is,
144.
and so that means that C squared equals,
169.
Feet.
169, but that's C squared. I don't want C squared, I want C. So I've got to take the
Square.
Again, normally we'd say positive, negative, but not when we're talking about a number of feet, a length. So you might be able to figure this out without the paper, but it doesn't hurt to have the paper. How long is this hypotenuse class?
13 feet.
13 feet. That makes sense? You do the last one on your own. I see a right triangle. I see 2 sides and I need a 3rd side. And I know a formula that can help me find it. Class, what do you call the formula?
Pythagorean Theorem.
The Pythagorean Theorem. What is the Pythagorean Theorem, class?
C squared equals A squared plus B squared.
All right, we kind of got the unison there toward the back end. Let's try it from the get-go here, class. What's the Pythagorean Theorem?
C squared equals A squared plus B squared.
Where the letter C, class, is the
Hypotenuse.
hypotenuse. The A and the B are the legs. Which side do I not know? I don't know the hypotenuse, so I'm just going to keep.
C squared.
But instead of A squared, I can either write
12 squared.
either 9 squared or 12 squared. Doesn't matter. The way I labeled it, I'm going to put 12 squared. But you could put 9 squared. For my B squared class, I'm putting
9 squared.
But if you had 9 squared, you'd do 12 squared there. Doesn't really matter. We know that 12 squared class is,
144.
and we know that 9 squared is,
81.
and if we add those two things together, Luciana, I get C squared equals,
225.
and so we might remember, because we saw this just a few minutes ago, or we might have looked it up on the paper. When we take the square root class, how long is the hypotenuse? 15 centimeters. Again, not positive, negative, because it's a length. But if this were not dealing with a length, we would put positive, negative when we take the square root. Questions on that? But look at the next section. Notice that first triangle in the next section. The 3 inches class, that's one of my legs. But the 5 inches is the hypotenuse. Well, the Pythagorean Theorem class says,
C squared equals A squared plus B squared.
but the C is the,
Hypotenuse.
so for this first triangle on that bottom section, what goes right here, class?
5 squared.
5 squared. And I know one of the legs, so I can say 3 squared, but I don't know the other leg, so I'll just leave it.
B squared.
Or if you're Bryson and you're a rebel, you're like, no, A squared plus 3 squared. Oh, what? Okay, fine then. He's not really a rebel, just for you. I'm just picking on Bryson because he's just sitting there by himself. He's just doing it, being a good student, working hard back there. I'm just picking on him. All right. He's like, yes, I am wise. All right, so anyway. All right, so 5 squared equals 3 squared plus B squared. Well, do what we just did. What is 5 squared, class? You're doing this right there with me. You're writing on your paper as I do on the board. 25 equals then for 3 squared?
9.
Plus B squared. Now here's the key. What do I have to do with the 9? Subtract it from both sides. That's going to get me 16 equals B squared. Now, to find the missing leg, class, we take the square root. And what is the square root of 16, class?
4.
4 is the square root of 16. Yes. So that means our missing leg, class, is 4 inches. So we'll label 4 inches for that missing side. Let's do another one. Look at the next one. Got some bigger numbers this time. But it's still a right triangle. And if I know two sides of a right triangle, and I want to find the third side, stay with me through the bell here. If I got two sides of a right triangle and I want to find the third side, I know I got to use the, which says,
C squared equals A squared plus B squared.
class, the 15 here is a
Leg.
leg. So one of these two's got to be 15. Bryson, which one?
Let's say B squared.
B squared. 15 squared in for the B squared. The 17 class, that's the hypotenuse. That has to be C. So I'm putting the 17 squared here. So the thing I don't know, class, this time is A squared. You're writing this down on your paper with me. Now, you have your paper there to help you a little bit. What is 17 squared?
289.
You can look it up, 289. If you don't have a paper on YouTube, you can just multiply it out. All right, but again, there's a link in the description of the video that has the little chart on it. A squared just stays A squared. 15 squared we might have memorized by now.
25.
Now, we've seen that a few times today. Now, what do I do to get the A squared by itself?
Subtract.
Subtract the 225. And when I do, I'm going to get A squared equals 64. Now what do I do, Elaine?
You get the square root of 64.
Which is
8.
8.
So that means that that missing leg, Elaine,
A equals
8
8 feet.
8 feet on this particular problem. Alright, now follow what we're doing here? You do the next one on your own. You do the next one. I'm going to keep you just a little past the bell here. I apologize. Got a little bit of a late start on this class. I need to make sure I wrap this up. We just got 2 more problems. We'll be done. What should I write first on my paper, class?
That's 29.
How about C squared equals A squared plus B squared? What do I write before the equal sign, anyone?
The 29 square.
29 squared. And then after the equal sign, Jalen, what did you write?
21 square plus 1 square.
And here's where it's nice to have the paper. We can look at the chart and see that 29 squared, class, is 841. We can also look at the chart and see that 21 squared is
441.
plus.
B squared.
All right, now what, Kirsten?
We have to subtract the 51
From both sides. There we go. And when I do, I'm going to get B squared equals
400.
Class, does that mean that this missing side is 400 centimeters?
No.
No, what did I forget to do?
Square root.
Square root. Don't forget that square root, Corey. You should get that the missing side is,
40 centimeters.
400 square root.
40
Well, let's find 400. What is 400 the square of?
20.
20 centimeters. How many at 20 centimeters? All right, last one on your own. Do that last one there at your seats. Nice, neat, careful, showing your work, showing every step. What do I write first, Griffin?
Just try to get, okay, there we go. 26 squared equals 24 squared plus B squared.
Well, I was going to say C squared equals A squared plus B squared, but I mean, you went ahead and did the plug-in, which was the next step. Then, when we look at the chart, what is 26 squared?
576.
Well, the 26 squared, sorry. 26 squared. Look at the chart. Chart. 26 squared.
670.
There we go. 676 was 24 squared.
576.
Plus the B squared. What do we need to do next, Joel?
You subtract 576
What is gonna give me b squared equals, class?
100.
100. So what must I do to finish it out here, Luciana? Take the square root, take the square root to get b equals 10. So what is this missing side going to be, class?
10 meters.
10 meters. Any questions on how the Pythagorean theorem works? And this is probably the most important application of a pure quadratic equation. Your homework for this evening is to do page 485 in the homework section, 1 through 13. Page 45 in the homework section, numbers 1 through 13.